Hello, do you know how to solder? Most would say yes, I've held a soldering iron in my hands before, but they still make basic mistakes that they don't even notice. Today I'll show you what you shouldn't do. Watch, pay attention, and never do what I do. Soldering is a process similar to gluing, but instead of an adhesive, we use molten metal. We just take two parts and connect them with molten metal. When the metal cools and solidifies, it holds the parts better than adhesive. When we solder two parts together, we use what is called solder. Solder is a metal alloy that has a low melting point. The temperature at which solder begins to melt is lower than the melting point of the parts being bonded. Let's say we are soldering copper, the melting point of which is 1922 degrees Fahrenheit or 1050 degrees Celsius. We are bonding it with a tin lead solder, which melts at 361 degrees Fahrenheit or 183 degrees Celsius. So when we are melting the solder, we don't damage the part in the process. Before you take the soldering iron to a part, make sure that part is not plugged into an outlet. If it is, unplug it. Of course, this is just a presentation, and my soldering iron and circuit board aren't plugged in. But let's experiment. I'll plug in the extension cord and carefully touch a contact on the circuit board with the soldering iron. We'll see what happens. You can solder tiny parts, like those of a phone for example. And of course a phone battery won't kill you, but if you short the circuit, you may never recover the phone. This is Flux. See what happens if I solder without it? I put the soldering iron to the wire, and it looks like the tin adheres, but it's very easy to pull it off because it doesn't cover the copper wire. Now let's see what happens if we cover the wire with Flux. Since the soldering iron is very hot, the part also heats during the process. The copper in the wire reacts to the oxygen in the air and oxidizes, and then what is called oxide film begins to cover the surface of the wire. Flux melts the oxide film and prevents it from forming again during soldering. Specifically, this wire gets as if saturated with tin. So Flux is something that lets you easily tin plate wires and other parts. Sometimes you need to solder parts that have been laying around discarded for a few years. Maybe these parts were acquired by your grandfather back God knows when. In this case, the oxide film on the contacts is so thick that even Flux won't get through it. I coat the contact with some Flux, try to tin plate it, but nothing sticks. The contact doesn't get tin plated. In this case, only mechanical treatment will work. We take the part, move the contacts outwards, grab a knife, and scrub the contacts until they become clean and shiny. Coat the contact with Flux again, and solder. That's it. So guys, this thing is called a soldering iron, and it's meant for soldering. I often see people use a soldering iron to remove the insulation from wires. First of all, that's just gross. Everything smokes and smells nasty. Second, the melted plastic penetrates the wire and makes it extremely difficult to tin plate. Don't do that. Let's try to tin plate this wire and see what happens. You can see the plastic that is stuck between the wire particles. Nasty. To do a soldering job, you first need to clean the wires well. Get some wire cutters. They don't cost much. Here you go, a clean wire without any insulation. Some Flux, a bit of solder, and you get a perfectly tin-plated wire. It's a problem if you have to solder something in the air. It's not just that your hands tend to shake, it's that the terminations are metal and conduct heat, so it really hurts to hold them in your hands. And you must hold the part, because if you let go right after soldering it, the part will fall down. So it's best to use soldering forceps or tweezers. While you are working, the tip of the iron will inevitably get covered in soot. This happens because the flux we use burns out and leaves trace on the tip. The old soldering irons that had a copper tip could be cleaned with a file. This won't work with new soldering tips. The reason being is that this tip has a copper core that is plated with iron and chrome. If you take a file to the tip, you'll just file off the plating and it will be very difficult to get the iron back to a working condition. So a file and soldering tip make for a bad combination. You see, the solder doesn't stick to it anymore, and you won't be able to work with this soldering iron. To clean these tips, you need a sponge like this. All you do is just wipe the soot off the soldering tip with a damp sponge. If you are working with an iron that has temperature controls, make sure not to set the temperature too high. Your tip will last longer if you set the temperature lower. But don't set the temperature too low either. If you do, the solder won't melt. Small pieces of the solder come off and melt on the tip. This doesn't look as good as soldering should. Despite the fact that it turns into a small shiny ball on the tip of the soldering iron, if you try to solder something, the solder will solidify too quickly, turning into a gray mass. This won't create a reliable contact, meaning that if we use this solder to solder at low temperatures, the elements we are working on won't adhere well. All you gotta do is pull on the pen and it will fall off. Let's say I soldered a pen and that's it, there's no contact. The best temperature to set on a soldering iron is the temperature of the solder. This is around 392 Fahrenheit or 200 Celsius, plus 100 Fahrenheit or 40 Celsius. Temperature between 464 Fahrenheit and 500 Fahrenheit, that's 240 and 260 Celsius, is ideal for soft solder. If you are using any other solder, just go online and look for the name of the solder. The melting point will be noted below it. Add 122 degrees Fahrenheit or 50 degrees Celsius to that, set this temperature on the soldering iron, and everything should be okay. Sometimes it happens that you've used too much solder, or soldered something in the wrong place. The great thing about soldering is that you can always desolder. All you gotta do is heat up the place where you've soldered and remove the element. If you use too much solder, don't try to remove it with the soldering iron. Of course, you can heat up the solder, remove some of it, heat it up again. The soldering iron will get most of the solder. You can shake it off again and do this forever. But the circuit board doesn't like high temperatures, especially high temperatures applied to it for a long time. If you try to desolder this way, the trace will likely break, and you'll have to repair it. To remove solder from a component, you should use a solder wick. It's this copper braid with pre-applied flux, which is great at absorbing solder. All you do is put it on the element you want to desolder, place your soldering iron on top of the wick, and wait. No more excessive solder. There are different fluxes, including this great acid flux. There's also soldering acid. These are active fluxes. It's very easy to solder with them, and they remove the oxide film nicely. But with the oxide film, they remove the components themselves. Not right away, but if you don't remove the flux, in 6 months or so the device will turn into mush. There are active fluxes, which are those that contain acids, and there are neutral fluxes, or those that don't contain acids. When we are done soldering this comb, and we'll be done very fast. Very fast. Just a little more. Here we go. When we are done soldering the comb, the board doesn't look very presentable. We need to clean up the board so the acid in the flux doesn't corrode all the contacts. To do this, you can use isopropanol, alcohol, or just a good cleaning solution in water. I have acetone and a toothbrush. There you go. The flux is removed, and the board is looking good. This flux is very difficult to remove from the board. Right here in the openings where the components were soldered, there may be cavities where flux will hide and continue to do its dirty job, corroding the contacts. So it's best to solder with a no-clean flux, or a neutral flux. Soldering is like riding a bike. Once you know how to do it, you'll never forget. But to know how to do it well, you need to practice. You can practice by soldering circuit boards, or you can make a simulator of a sort. I'll remove the insulation from a long piece of wire, and we'll cut the clean wire into 10 centimeter pieces. I'll need 20 of these. Now I make a mesh out of them and solder all the connection points. This method is old as time. I think I saw it in a magazine dated 1976 or 78. Nothing changed, you just need to take a soldering iron and start soldering. Now that I'm done with the mesh, what do you think it's for? You'll need it to assess your work, which is easy to do. Take the mesh and start bending it every which way. Do anything to it to destroy it. And look at how many soldering points break apart. Here you see the wire itself broke, and here the wire broke, but the soldering points are still intact. It means the job was done well. You can use solder printed circuit boards, or use point-to-point construction, or create works of art from your circuits. I hope this video was useful and you learned something new about soldering. Level up your skills, solder more, and use the link below to get everything you need for a good soldering job, the tool and supplies. See ya!